All right, folks, so the last type of graph that you are going to look at looks like this, and it is called a logarithmic graph. Okay, so we're graphing a logarithm. Okay, and I say this, and I feel like sometimes people look at me like I'm silly, but trust me, I've asked people this question and they haven't been able to answer it. So, how do you know that this is a logarithm equation? Because it's got the big log at the beginning, okay? So that's what makes the equation itself a logarithm, and that's what tells you you're going to have this specific shape. So first off, I'm going to make one other little note at the bottom, all right? Logarithms are, aside from being exponents, inverses of exponentials. Okay, I bring that up because you should have learned very, very recently that exponentials have asymptotes that are that are y equals some number. Okay, so what's the inverse of having the variable y? Like if you flip y, it would become x. And that's important because if you look at this graph right here, you should notice that there is this vertical dotted line here, okay? And the only way to get a vertical line is to write it as x equals. And so this particular vertical line would be our asymptote for our logarithm, which is x equals 0. So again, there's an asymptote here, just like with our exponential function, but it's going to be x equals a number every single time. So then what does that affect? Well, that affects the domain instead of the range. And so when we look at this function, now we're looking at the fact that the graph starts here, kind of around 0, and then it keeps going on and on forever to the right. There's no graph to the left of 0. So that means that the domain would be from 0 to infinity. And by the way, I didn't mention this in the earlier video, but the reason why the 0 doesn't have a bracket around it is because we are never going to be equal to 0. The asymptote is actually indicating that we can't be. We're approaching but never touching. We're getting close but never equal. Okay? So then let's talk about this other piece of our characteristic, which is our range. Okay? And so if I just look at this shape, I can see that it's going up forever slowly. So that's positive infinity. And it makes this sharp downward turn running parallel to my y-axis on forever and ever to negative infinity. So that means my range is now negative infinity to infinity. So what happened? Because the logarithms are inverses, everything, all the characteristics switch variables. So for exponentials, the domain is all real numbers. And for logarithms, it's the range that's all real numbers. For the exponentials, the asymptote is y equals a number. So here it is x equals a number. Okay? And then I want to talk about a couple of other things, like how do I get these points? Okay, well, it can be kind of tricky to think about, but there's two easy values to calculate if we needed to make our own logarithm graph. So the first one is it's very easy to plug in 1 because the log of 0, because the log of 1 is always 0, right? So that's this point right here. 1 in, 0 out. And then it's just as easy to plug in the base because the log base 4 of, in this case, 4, what we're plugging in, would just be 1. So that's this point right here. So there's a couple of easy values you can always do for the logarithmic graph. You can always plug in 1. And you can always plug in whatever the base is, all right, or whatever number will get you the argument to be equal to the base, because you're always going to get 1, 0, and then base, 1. All right, that's how that's always going to work, okay? So hopefully that gives you a little idea of, and the logarithm shape, by the way, is always going to have this like long tail down at the bottom, and then it's going to curve really, really slowly, you know, very much the unexponential function. It's going to move really, really slowly. Okay, so enjoy looking at your logarithm graphs. Thanks for listening so much. Bye, folks.